Let's take a look at some exponent rules. So to continue with Unit 4 here, we're going to look at the rules for performing exponent operations or operations with powers. And so we'll just do a few of these. We'll go through a few rules, practice the operations, and see how it goes. So first we have the product of powers rule. So product is multiplying. And if you multiply two powers with the same base, we're going to multiply the coefficients and add the exponents. So the coefficients, the numbers out front, those get multiplied as normal, but the exponents you can add together because, again, we're just counting up how many of that base you have. So the structure here, x to the a times x to the b, is x to the a plus b. Add those exponents together. So for example, x to the 5th times x to the 6th, we're going to add those together. That would be x to the 11th. And that's just because we have 5 x's being multiplied together. We have 6 x's being multiplied together. And if you multiply those two things together, we have 11 total. Right? It's just counting up how many of that base are being multiplied. Example B, we have 2x to the 6th times negative 7x to the 8th. So the coefficients get multiplied as normal. 2 times negative 7 is negative 14. The exponents get added. 6 plus 8 is also 14. So negative 14x to the 14th. For example C, we have negative xy squared times 3x cubed y to the 7th z. Remember, any power with no exponent has an exponent of 1, and this negative sign, you can think of that as a negative 1, which will then multiply by the 3 to get negative 3. And then we can just go letter by letter, base by base, and add up the exponents. X to the 1 plus 3 is 4. Y to the 2 plus 7 is 9 to the 9th power. And then we just have the 1z, which will go on the end. All right, so multiply the coefficients and add the exponents on different bases. Power to a power rule, this is similar, but essentially when you take power to a power, you multiply the exponents. And this is because multiplication is just repeated addition. And so when you take a power to a power, you are multiplying it by itself that many times. So you can just multiply the exponents. This also happens if you have a fraction. You apply that exponent to the numerator and to the denominator in the same way. Exponents get applied to coefficients normally because those are just numbers. Multiplying the exponents is just a shortcut, but you do still need to apply exponents to coefficients normally. So x squared to the 3rd, that would be x to the 6th. You can think of this as x squared 3 times, right? So that's 2 plus 2 plus 2, or 2 times 3, x to the 6th. For example B, we are going to apply this 4 to each thing inside the fraction. That would be x to the 8th, y to the 12th, over z to the 4th. Remember, there's a 1 there. 1 times 4 is 4. And example C, 4x to the 5th, all to the 3rd power. 4 to the 3rd power, that's 4 times 4 times 4. Because remember, this means we have 3 for x to the 5ths. And so what we can do is use a little shortcut and just do 4 to the 3rd and then multiply the exponents. 4 times 4 times 4, 4 to the 3rd power, that is 64. Yeah, it's 16 times 4. And then x to the 5th to the 3rd, 3 times 5 is x to the 15th. So 64x to the 15th. So apply the exponent normally to the coefficient, 4 times 4 times 4. But then you can just multiply 5 times 3 because that is just 5 plus 5 plus 5. All right, quotient of powers rule. This is division. It is basically the opposite of multiplication. And that even should say dividing right here. When dividing powers with the same base, divide the coefficients, and subtract the exponents. So x to the a over x to the b is x to the a minus b. So we just subtract. So x to the 10th divided by x to the 3rd, 10 minus 3, that is x to the 7th. And that is because if you have 10 x's divided by 3 x's, the 3 on the bottom cancel out 3 from the top, leaving you with 7. So that's x to the 7th. 16x to the 3rd over 2x to the 5th. Now 16 divided by 2 is 8. And 5 minus 3 is 2, but notice the 5, x to the 5th, is on the denominator. So that is where our answer will end up. We have x squared on the bottom. That's the simple way to think about that. In reality, we get a negative exponent. We get 8x to the negative 2 power. But we will talk about that in the next section. So it is sufficient to say that wherever the bigger exponent is, that's where your answer will end up. So x squared will stay on the bottom of that fraction. All right, 3x to the 4th y to the 9th over 9x to the 4th y to the 5th. For some of these, I like to just start with my fraction bar, and then I put things where they go. So 3 over 9, we're going to reduce that because 3 divided by 9 is 0.3 repeating. It doesn't divide evenly, but we can reduce that as a fraction. We get 1/3, like that. And then the x to the 4th over x to the 4th, those cancel out. 4 minus 4 is 0. And then we have 9 minus 5 for y's, so that's y to the 4th power on top. So our answer is y to the 4th over 3. Or if you like, you could always change that to 1/3 y to the 4th, but I don't think that's necessary. All right, let's talk about negative exponents. So whenever you have a negative exponent, it indicates a reciprocal of sorts. So put the power to the other side of the fraction bar, wherever it is. So x to the negative a would be 1 over x to the a. 1 over x to the negative a would be x to the a. So wherever it is, if it has a negative exponent, move it to the other side of the fraction bar. So for example, x to the negative 5th would be 1 over x to the 5th. 3x to the 4th to the negative 2. So whenever I have a negative exponent being applied to something like this, I like to think of it as just 1 over and then change that to a positive, and then you can mess with it. You could put that negative 2 on each thing and then simplify, but I like to take care of the negative part first and then deal with the number. So this is going to be 1 over 3 squared is 9, and 4 times 2 is 8. Just like that. And then x to the negative 6 over y to the negative 3rd. We just need to flip these. They are different bases, so we can't combine them. So we have y to the 3rd over x to the 6th. And finally, the zero exponent rule, the most difficult rule on this page. Anything to the power of 0 is 1. That's all there is to it. So anything to the 0 power is going to be 1. So for example, 5a, we have x to the 5th over x to the 5th. That is x to the 0, which is 1. They cancel each other out. We're left with just 1. 2x to the 0, y to the negative 3rd. Well, this x to the 0 becomes a 1. 2 times 1 is 2. This kind of just goes away, and leaving us with 2 over y to the 3rd. We don't want to have that negative exponent left there. And then we have this relatively complicated one here. We've got a few things to simplify. So let's take care of this up here first. 2 to the 3rd, that's 2 times 2 times 2 is 8. X to the 15th over 8 x to the 10th times, now this negative, again, this is going to flip it. So I like to flip it first just to simplify a little bit up here. It'd be x cubed y over 2x cubed y to the fourth, all to the now positive second power. Now let's simplify that part. So x cubed to the second is x to the sixth, y to the second, over 2 times 2 is 4. We have x to the sixth, y to the eighth. Now we have this problem here to multiply. There are a few things we can take care of before we do that. X to the sixth over x to the sixth, those will cancel each other out. 6 minus 6 is 0, which is 1. And 8 over 8 will also divide to 1. And now we can simplify a little bit more before we multiply, or you can go ahead and multiply first. Maybe I'll do that just to simplify things up. So on the top we have x to the 15th, y to the second, over x to the 4, don't forget the 4, 4x to the 10th, y to the 8th. And now we can simplify that one more time by subtracting our powers. So 15 minus 10 is 5. We have x to the 5th. 8 minus 2 is 6, but it goes on the bottom for y. And it'll stay down there with that 4 as well. So x to the 5th over 4, y to the 6th. That is the final simplified form of that big mess right there. Now we kind of used all of the rules at once. So there you have it, several exponent operation rules. Anything to the 0 power is 1. A negative exponent indicates a reciprocal. Move it to the other side of the fraction bar and make it positive. When dividing powers with the same base, divide the coefficients and subtract the exponents. Power to a power means you multiply the exponents, apply exponents to coefficients normally, and when multiplying powers with the same base, multiply the coefficients and add the exponents.